All right. So we are going through OSPF, Open Shortest Path first. So let me brief it first, whatever we covered in the previous class, and then we will do the lab. Okay. So basically, I want to do the lab for all the topics that we discussed in our previous classes. Okay. So let me open up OSPF. Well, okay. So from my previous class, the first slide or the first topic was all the keynotes about OSPF. Okay, so I'm not going to repeat each and everything. I'll just randomly take some points and just go through it. Okay, so this is already put up on the web portal. So go and open up the document or download it and just go through this. Okay, fine. So as we know, open shortest path first. They are a distance. They are a link state vector. Okay, they're called as a link state vector, and they support VLSM. They have password authentication to protect their packets that's flowing between two different routers. Okay, so the OSPF packets can be password protected. There are two types. One is MD5 password protection or plain text password protection. They they have a load. They do load balancing, but only on equal cost, not unequal cost. Okay. The IP protocol is 89. The AD value is 110. These are the two multicast address. Okay. 224.0.0.5 and 224.0.6. This is the hello packet. This is the hello timer. Hello timer by default is 10 second, and dead timer it's 40 second. And yes, OSPF support VLSM, that is variable length subnetting mask. OSPF also supports summarization, route summarization, and in the case of route summarization, it's your ABR, area border router, where the summarization happens. Okay. So while configuring OSPF, make use of wildcard mask, not subnet mask. Okay. So you have area concept in case of OSPF. You will be learning uh, about areas, the different types of areas. So basically these are logical. Okay, so these are to be logically configured. Okay, these are some sequence number. Every sequence number will start with this and every sequence will end with this. Okay, and then they will be incremented by 1. And OSPF will have periodic update as well as instant update also. Let's say if something goes up or something gets added up, then it's going to be instant. And let's say if there is nothing happening, then there will be a periodic update as well happening. Okay, so what else did we go through? We went through OSPF packet types. So we have 5 packet types. One is hello packet type, database description, link state request, link state update, link state acknowledgement. But to understand this, we first covered up the 7 states in OSPF neighborship. Okay, so down in it, two-way extract, exchange, loading, full. So basically these are the steps where the two routers, okay, they form neighborship as well as they exchange their database. And at the end of the 7th state, so basically whatever the network that R1 knows, let's say this is R1 and this is R2. So let's say R1 is aware of 10 networks and let's say R2 is aware of another 15 network. Now they exchange their information. Okay, so at the end they will be aware of 35 networks over here and 35 networks over here. So basically the database will be consistent throughout in the case of OSPF. Okay, so it's not about only two routers. Let's say there were multiple routers, something like this. Okay, something like this. Now let's say all are part of OSPF. Now every router will go through these 7 state, and at the end they will be aware of all the 35 routes that is being introduced or been learned in this network topology. Okay, so that's a good point, as well as it's a drawback in if you talk about the memory utilization, then yes, it's a drawback, because to process each and every database or every packet and the periodic update, there will be extra overhead put up on these routers. It's good from the point of split horizon. Okay, so there will be very less chance of looping happening, because from router, let's say this is router 10. Now from router 10 point of view, it's aware of every network that's behind other routers. Okay, that's a speciality about link state vector, whereas your distance vector or the RIP, basically they will only know how to reach their neighbors. Okay, or they just know about neighbor, but the neighbor, how is it connected or who is connected, that's not visible to the main router. Okay, so that's where you have the looping occurring and all other things. Okay, fine. So these are the 7 steps, which is very important, and all these 7 steps will be taken care by these packets. Okay, the initial packet will be hello packet, which comprises of router ID as well as some parameters. Okay, so what are the parameter in the case of hello? So you must have uh, the matching area ID, you must have the same area type, you must have the same hello and hold timer between the two routers, that's forming neighborship. In case you have authentication, set it up on both of them. If no, don't set it up, it's an optional case. Okay, you must have the subnet mask, equal subnet mask. Okay, so these are few parameters that will be taken up in the starting phase. So let's say I have two routers, I just bring up the OSPF process. Now the hello packet will be taken up, and the content of hello packet is these things. Okay, fine. So once they form neighborship, once the two-way state is achieved, the database description packet will be taken up, the master slave will be elected up. Okay, and then they decide who starts sharing their database first. Okay, so it's your master who will send or who will share the database first, and later on, to know more about any network, your master is going to send a LSR packet saying that I want to know more details on this network. Okay, now the R2 has to send the information about this to R1, and then that's packet LSU, and then the first packet will say thank you, or it's called as thank you receipt, which is a acknowledgement packet. So these are few packets which we can see under the 7th state. Yes, these are the hello packet content. Okay, which we can also see over Wireshark. Okay, router ID. What is router ID? So basically it's a 32-bit number, or it's a IPv4 format. Okay, router ID are always in a IPv4 format. How do we set this? There are 3 ways. One is manual way, or else if let's say we don't have any manually configured lines for router ID, it's going to take the highest loopback. Now let's say there is no loopback, then it's taking the highest physical IP. But router ID is must. Without router ID, your OSPF process will not come up. Okay, fine. So states were discussed. We know what is designated router and what is backup designated router. So in the case of multi-access network, okay, to reduce the unwanted broadcast, we select one router to be DR, and we also select one backup DR router. Okay, so what happens in this scenario is all the update will be first sent to DR only. Okay, on which multicast address the information is sent, it's sent to 224.0.0.6, and then DR is going to update its database table, and then DR is going to send it across to all other routers on 224 0.0.5. Okay, so this is elected in order to avoid the unwanted broadcast happening. Okay, how is DR and BDR selected? The formula is priority plus the router ID. Okay, by default priority is 1 in the case of OSPF. Now let's say in such scenarios, okay, let's say this is a lower end router. Okay, let's say this is some ISR 800 router and rest are all 1800. Now you don't need this router becoming DR or BDR at any reason. Okay, so what you can do is you can set priority to 0. Once you set priority to 0, they will never form DR or BDR. They are always selected as a DR others. Now this is the third category. Okay, we have DR, we have BDR, and the rest of the routers will be called as DR others. Now DR others will be seen most of the time in two-way state. Now there is a very famous or very frequently asked technical question. Uh, if you see DR other, it's a good example or it's a bad example. So you must know that DR others are always seen in two-way state. Now this doesn't mean it's a bad example. Okay, it's just they have formed the neighborship but they are not forming adjacency. Okay, so that's why they are kept in a two-way state, and DR other will be always in two-way state only. It's your BDR and DR and BDR which will form full adjacency. Okay, you know what is full adjacency when they go over 7th state, that's called as full adjacency. In the case of DR other, it just go through the first two state only, that is init and two-way, and they form neighborship and they are as it is because their involvement is not required in the network. But let's say for some reason this goes down, DR goes down, now BDR will be elected as DR and one of the DR will be put into BDR. Okay, so they are just kept handy. They don't serve any purpose. They are not neither DR or BDR, so we don't need to send the packet or their intervention is not required until the main DR goes down and then one of them comes to and take up the BDR role. Okay, so yes, someone is asking you whether let's say DR is stuck on two-way, so it's a good or bad. So you can say it's a good example, or you can just say they are they are seen in two-way just to avoid any response, or they're not sending any kind of DPD packets. Neither they are sending any LSR, LSU, or LS acknowledge. Okay, so to avoid unwanted hello packets or to avoid unwanted OSPF packet, we just keep them in two-way. So what happens in two-way is only hello packet is being shared, or only the hello packet will be sent between the two routers just to make sure router is up or no. That's all. If there is requirement, they will go through all the remaining step, that is extract, exchange, loading full, and then they will be put up into BDR state in case DR goes down. Okay, so DR, BDR, and the last state is DR others. So we will do a lab and we will see how this work. Okay, so don't worry, give me like a couple of minutes and we will do this lab. Okay, okay, designated router and BDR routers as I told here. So you have DR, BDR and DR other. So let's say in a multi-access network, you have one DR, you have one BDR, rest will be elected as DR others. Okay, and if you notice the neighborship table, these are the two state which will completely go till full adjacency, whereas DR others will be put up in two-way. Okay, now that's not a bad example. It's just because we don't need the unwanted packets flowing across. We don't need LSU, LSR, or always all those things. Okay, if something is impacted, then that router will send those packets. Otherwise they will just share hello packet among themselves just to make sure they are up and alive. Okay, so that's something which we will do lab and we will see. Configuration, yes, there are two types we can configure OSPF configuration. One is global way. The second one is interface specific. As I told you, global way or centralized is much better when compared to interface. The reason is, over on interface you will be doing lot of multiple other configuration also. Might be you're doing a by forwarding detection, or might be you're doing some manipulation on timers. Okay, or let's say you have any other protocol that is interface specific. Now the chances are that these timers or these protocol take a superior or uh, higher privilege than OSPF. Okay, so whatever configuration you have for OSPF will be suppressed. Okay, so in order to avoid this overlapping, what we do is we just keep OSPF under centralized. Okay, we keep this under centralized mode, and all rest we can just keep it under interface. So the configuration is pretty okay for both. There is nothing much. Okay, centralized, just one command and bring up the network. In the case of interface specific, go directly to the interface and mention the network that this interface belongs to, and then power on the OSPF process by IP OSPF1 area, and you can just uh, mention the area or whatever it is. Okay, passive interface is something when, let's say, you don't want that interface to be advertised. Okay, so let's say this is a router R1 and this router is advertised with other routers. Okay, similar way R1 is also having some network of 1.1.1.0/24. Okay, now this network, this particular network, you don't want to form any sorts of OSPF neighbor. Okay, let's say this R1 which is connecting to, let's say, some branch router or something. You don't need some you don't need this. There should be some OSPF packet flow or something. Okay, so what you can do is you can just put this interface on passive. As soon as you put this interface on passive, your OSPF hellos will be stopped. Okay, there will be no OSPF hello packet sent on this interface. Also, let's say you received some hello packet or any kind of LSR packet, LSU packet on this interface, so that's going to get dropped. Okay, at the same time, this network will be still advertised to the other guys, other routers in the network. That's a main thing here. Passive interface, you're uh, suppressing the packets. That doesn't mean that you're suppressing the network. The network will be advertised. Okay, so the network will be still advertised. That's the advantage here. It's the easiest or the quickest way to advertise this network segment to the OSPF router. Okay, but for a easy to have some or to reduce the unwanted packet flow or overhead on routers, we can just put them in a passive mode. Okay, so as soon as they are put in passive mode, the OSPF hello, and they do not process any kind of OSPF packet that's received here. Okay, but still they will be advertising that 1.1.1.0/24 network. Okay, this is the requirement for OSPF neighborship. Okay, these are few factors which we discussed in the last class that should be taken care, so that the OSPF neighborships are formed. Okay, okay, and then we had the three tables. One is the interface table, then we have the topology table and the routing table. So we will discuss this. Okay, fine. So before I go ahead with any theoretical topic, I'll take up the lab. Okay, so for now, for today, I am going to take this session of my whole topology. Okay, this one, and I just labeled it with one of Indian city, Mumbai. Okay, so what is what here in this scenario, in this lab session, I'm considering multi-access OSPF. So we should be seeing DR and BDR happening here. We will see all the other components that was discussed in the last class, that is the component within hello packet, okay, the 7 states of neighborship. Let's say if I change the hello timer from 10 to make it 20, okay, and rest are still having the default timer, and we will see if the neighborship is built or no. Similar way, I'll bring authentication. I'll change the area type. I will change the area ID. I will do lot many things to just make sure on which configuration the OSPF will go down and on which the OSPF will remain. Okay. So something which is very important from the interview point of view. Okay. Because if someone asks you that if my neighborship is not coming up, so you must explain the whole technical point that what could be the reason. Okay, and until you do this practically, you will not remember on why that's causing an issue or something. Because on other side, if you talk about EIGRP is going to ignore all these things. They are still going to become neighborship. But in the case of OSPF, they are very sensitive. You just change one timer between two routers, they will not form they will not form neighborship. Okay, so that's something which we will discuss in the class. Apart from that, I will show you the three tables, that is neighbor table, I'll show you the database table and routing table. So while discussing the database table, we will be talking about LSA, link state advertisement. Now they come in multiple types like LSA 1, LSA 2, LSA 3, 4, 5, 7. Okay. So we'll go over on this LSA. We will see where do we see this, what is this. Okay. So something, some practical for the theory we covered in the previous class. Okay. And in the next class, that's tomorrow, I'll take up advanced OSPF. So under advanced OSPF, uh, we have passive topic, we have the cost calculation topic, we have areas, link state, okay, then discontinuous networks, path selection, route summarization, route filtering, and default route originate. So this will be covered up in the next 2 days. Okay, so basically this week is all together for only OSPF. Okay, and let's start the lab. So I'll power on these devices. Okay, so I believe it's properly visible now. All right, so we have the required routers powered on. Okay, so I need some initial IPs. Okay, so for initial IPs, let's bring up the workbook. Okay, I think I have it over here. So this is my workbook. Let me go to the OSPF section. Okay, OSPF. Okay, so each router will have their initial basic configuration. That's with respect to the IP address. The rest, configuring OSPF, is something which we are meant to do. Okay, so fine. So let me open up the console of these devices. All right, so I have one, two, three, the Mumbai R4 router and Mumbai R7 router. So let me see, do I have any initial configuration? Okay, so I have two IPs configured. So on my router 1, that is this router, I have a interface IP and I have a loopback IP configured. So the same pattern goes across on all of them. Two IP address, one is physical IP and one is a loopback IP. Okay. Great. So we have all the basic IP configuration. Now, how do I get that? So basically, that's over here. Okay. So while you guys doing the lab practice, so basically you will find the initial configuration on the lab, on the workbook itself. Okay. So just copy paste it. Okay. So that's your initial configuration. Now let's configure OSPF here. So let's bring up the OSPF configuration here. So what can I do is I can bring up some debugging first. Okay, so let's open debugging for OSPF packet and as well as agency. Now let me go to configuration and let me bring up the OSPF process. So let's give some process ID. Okay, so as I told you, process ID is locally significant. They don't have to be matched in two routers. It don't have to be getting matched in Mumbai router 1 and Mumbai router 2. Okay, it's a locally significant value. So I'll give it as 100. Now what are the two networks that I want to advertise here? So from my configuration, it would be this, which is a /24 network. And as we know, in the case of OSPF, it's a wildcard mask. Okay, what is the area? Area is 0. And along with this, so you can see the agency neighbor interface going up. Okay, along with this, there is a loopback interface which has to be advertised. Okay, I'm not going to set any router ID because that's one of the tasks of this workbook. So we will see how the router ID was taken up. Okay, so I have my OSPF configured. So these are OSPF configuration. Okay, but I don't think there will be any neighborship happening. The reason is, on the other side we don't have any sorts of OSPF configured. So what is happening, as soon as you are bringing up the OSPF process, you can see your router is making itself as master, it's making itself as DR, and it's sending the information. Okay, so basically first it elects itself as BDR and then it will elect as DR. Why do it elect itself as BDR and not DR? The reason is, it doesn't know that who is connected to me or who else is in the network. Okay, so it doesn't want itself to be called as DR at the first point. Okay, it elects itself as BDR, which is backup DR, Now let's say it don't find anyone else in the network, and now it will elect itself as DR because there is no one in the topology. Okay, so this is one more interview question. Which state get elected first? It's your BDR that gets elected first. Okay, now if there is no one in that topology, now that router will elect itself as DR. So that is what happened here. Okay, fine. So that was the first configuration on one of the router. Now let me go to the second router and let me bring up OSPF process. So I say router OSPF. What are the two networks? It's 192.168.23.0, 0.0.0.255 area 0, and I also have loopback to be advertised. So that's 2.2.0. Okay. So these are the two networks that I want to be advertised. Okay, so if you see now, there is already one of the pair one of the two routers have formed the neighborship. Okay, so it says that loading to full. Now let's see from the other side where I have the debugs enabled. So let's see what happened actually. Okay, so if you remember, it was a single router, single point of router. It elected itself as BDR first and then DR next. Okay, now when it see there is some router on the other side, or and then what happens is if it receives any hello packet from that router, it will now start sending its own hello packet to the router. It will also see there are hello packet coming in from different destination. Okay, that is where they will form two-way communication. So let me just stop this for a minute. Okay, so they are forming the initial neighborship. So you can see here the two-way communication. So two-way communication is when this router, that is Mumbai router 1, knows that there is another router in the network which is capable of OSPF, packets, or which can listen to the OSPF and which can also send the packet on the OSPF multicast IP. Okay, so two-way is when they form basic neighborship. It's a neighbor change event. Now once neighborship is formed, now they will elect master and slave, which is happening over on DPD packet, database description packet. Okay, so NBR negotiated, we are the slave. So basically there will be election happening, who has to be master and who has to be slave. Now whoever becomes the master will be the first router who will share its database, complete database, not complete database, just the copy of database or header of the database, or just it will send one single copy saying that I have four networks. Okay, I am aware of four network, but it's not going to reveal which four network. That's happening in later on stages. Okay, so these are few things here. They went through exchange step, from extract exchange. Okay, if you see there was the MTU check happening here, and then the exchange was completed, and then they went to the full state. Okay, so you see here process 100 neighbor 2.2.2 on ethernet 0/0 from loading to full. So these are the 7 state that we discussed, and these 7 state are happening due to those OSPF packet, hello packet, DPD packet, LSR, LSU, LS acknowledgement. Okay, and rest are all the keep alive that is happening every 10 and 40 second. And let's verify all other things. Okay, so let's say, okay, just a minute. So let's see how do we see the OSPF neighborship table. Okay, so this is a neighborship table in the case of OSPF, and this is the command. Okay, so this is a neighbor 2.2.2. The priority set is 1. They are forming full BDR. Now what is full? full is those 7 steps. Once they complete those 7 steps, they achieve the full state. Okay, and after or during the election or during these 7 steps, they elected who would be DR and which one would be BDR. So in this case, the neighbor is elected as BDR. This is the dead timer. Dead timer in the case of OSPF is 40 seconds. So you will see this as a timer which starts with 40 and goes towards your 10. Okay, like uh, 40, 39, 38, 37. So that's called as hold timer or dead timer. Okay, let's say if two routers are not okay, let me tell you how this hold timer helps you. Okay, so let's say I have two routers. Okay, R1 and R2. I have 10 and 40 second as my hello and hold timer. Now let's say I am sending 4 consecutive packet. First 10th second, the next one goes around at 20th second, 30th second, and 40th second. Now if this is not going to reply back, then then this router is going to declare this as dead. Okay, and this neighborship will be taken down. So basically, these hello packet must be replied back. Okay, so that's the timer here. So if the timer get lapsed and there is no hello packet received from the other end, then this neighborship will be totally taken down. This is the address of that neighboring router, and this is the interface where this neighborship is happening. Okay, so this is the primary address for the OSPF neighbor. So if I show you the topology, I have the OSPF forming between this and this. Okay, so as my neighbor, I see the neighborship is built on 2.2.2.2. Okay, so you can see the neighborship is built on 2.2.2. Now what is this address? This is the primary address of this router, that is 23.13. Okay, 23.13. And on which interface are they forming neighborship? That's over on Ethernet 0/0. So that's the table, and it's called as OSPF neighborship table, and these are the some factors within the OSPF neighborship. Along with this, there are a different or separate table that OSPF is going to maintain, that's called as database table. Show IP OSPF. So let me show you database table. Okay, so if you see this database table, this is little weird than all other routing protocol, like for example EIGRP. So in this case, all the links will be stored. That's why we call this as a link state vector. If you talk about OSPF, they are going to maintain every links. Okay, so it knows about 1.1.1, it knows about 2.2.2, and it also knows about the 23 network. Okay, so this is the advertising router who is advertising these link IDs. So in this case, 1.1 is advertised by this router. This is the age of this link. This is the sequence number. If you remember, I was talking about sequence number in the beginning of the class. Okay, so that's what is the sequence number. This is the checksum value. Okay, so checksum value is something which comes with respective to authentication. Okay, in the case of authentication, the checksum value will be calculated, or a hash value will be calculated. Now this hash value is representing some authentication in the backend. Okay, at this moment there is no authentication, so this checksum value is a dummy value. Now let's say I set up some authentication, this hexa value will change. Okay, similar way, link count, it says 2. Now that means this router knows about 2 different network. Okay, so in this case, what are the 2 network that this router is aware of? It is 192 network and that 1.1 network. Similar way, the advertising router 2.2.2, that is the R2 router, Mumbai router, this is the age of this route learned, this is the sequence number, this is the checksum, and it also know two different route. One is loopback and one is the physical link. Okay, so if you talk about this router, it is aware of two different network. One is the physical network and one is the loopback network. So that's why you see as a count 2. Okay, now if you see, there is one section and then you have the second section. Okay, now what is this? Now these are called as LSA. Okay, link state advertisement. So very important topic in OSPF. Your whole OSPF is built over on LSA, or you can say LSA are the building blocks for OSPF. Okay, without LSA, OSPF is nothing. Now, why is it so important? So let's say as of now, I see two types of LSA. One is this, which is called as okay. So what I can do is, since there are some, I'll just take the screenshot of this. Okay, so there are two LSA packet at this moment. So one is this and the second one is this. So this is called as link state advertisement type 1 and this is called as link state advertisement 2 or type 2. The first one is called as router type, and the second one is called as network type. What is router LSA going to show us? It's going to show us the neighbors, the direct connected neighbors. So let's say I have two routers. Now how are they connected? On one side I have 1.1.1 and I have 2.2.2. So on my first LSA, I will be only seeing the directly connected information. So let's say this router was connected to one more router with 3.3.3.3 and 4.4.4. Now this becomes a part of LSA 1. Okay, LSA 1 is representing the directly connected information only. Okay, now what is LSA 2? What is network now? Now network is something which is going to show you the network associated with these routers. Okay, so in this case, your 1.1.1 is also advertising another network, that is 192.168.23. So basically the networks will be learnt in case of LSA 2, okay, which is called as network type. Now you see here there is area 0 and this all advertisement is happening within area 0. Okay, now let's say I bring up some different area. So once I bring up this area 10, you will see your ABR router, area border router, will start advertising these LSAs. Okay, now there will be LSAs which you can be reading it over here on the router, which is part of area 0. If you go with show IP OSPF database, so you can see some other area, some other LSAs, okay, like LSA 3, LSA 4, LSA 5. So this list will get expanded. Okay, as of now it's just two neighborship, that's why you are seeing just three different links. Now imagine you had different areas, you had some external routing protocol, or you had multiple areas. Now your links will be getting increased. Okay, so as of now let's remain to the first basic LSA. In the next class I will go ahead and tell you the different LSAs that we would be seeing up. Okay, so LSA 1, LSA 2, LSA 3, this is from the point of basic level. Okay, LSA 1, LSA 2 is clear. LSA 1, LSA 2, what is LSA 1? Direct connected information. What is LSA 2? The network that's been advertised. Okay, now what is LSA 3? LSA 3 is called as summary LSA. Okay, now who is summary or what is summary? So basically that's nothing but, let's say I have two different area, one is 0, one is 1. Now if you want to know the routes, or if you want to know the network that's part of area 1, now your LSA 3 will be transported. Okay, so these information will be taken to area 0 on LSA type 3. Now that's called as summary LSA. Okay, that's been originated by ABRs. Your ABR is going to originate this summary LSA. These are nothing but the information about other OSPF areas. It could be area 1, 2, or 40, or anything. So any other area information, if you see inside area 0, now that's taken care by these LSA 3. Okay. As of now, we don't see that. The reason is I have not configured any other area. I'm still running on single area. Okay, so when you have the configuration on single area, we call it as single area. Now let's say if I bring up multiple areas, then we call it as multi area OSPF configuration. Okay, so in those scenario, we will see the LSA 3 coming up. As of now, there is nothing. Okay, so I'm going step by step because I don't want you to show all 7 LSA at the end of the class or something. So as of now, the first step, there are only 2 LSA happening. Now as we increase the configuration, you will see lot of LSAs coming in. Okay, so that's my intention here. Okay, so I configured single area. I have seen the seen the database table. I see the LSA. Now the third table here is the routing table. So there is only one OSPF route learned in this topology. Okay, that is 2.2.2. Where is 2.2.2 from the topology? It's behind the router 2. Okay, so from my router 1, if I see the OSPF learned route, so I can see that this route is learned on OSPF protocol. Okay, who is advertising and on which link or which interface this is being learned, that is shown over on our topology table or routing table. Okay, so 2.2.2, the AD value is or the administrative distance value of OSPF is 110. 11 is the cost, okay, or the metric. We will see this how the metric is calculated. We will try to manipulate metric, and we'll do a lot of path selection lab also. Okay, so this is cost value, cost taken up over here from this and from this to this. Again, it's your existing or the outgoing interface that's contributing to the cost. Okay, that we also checked in the case of EIGRP. So it's your outgoing interface which adds up the cost. And let's say this was 10 and this was 1. Now that's getting added up here. Okay, so it's an outgoing interface cost that's get added up, not the incoming one. Via 23.13, that is a physical IP over here on this interface E0/0. Okay, and that's the timer or the age of this route that was learned. That's 15 minutes back. So the 3 tables we discussed. Okay, fine. So let me go through the workbook. Let's see what do we have here. So we did the basic configuration. Okay, now I'll bring up OSPF on the third router as well, so that I can show you the DR and BDR configurations. Router OSPF 100, network 192.168.23.0, 0.0.0.255 area 0, and network 3.3.0, 0.0.0.255 area 0. Okay, show IP int brief, exclude unassigned. So we have this network and this network, so I'm advertising both of them. Okay, and let's see what is the OSPF neighborship over here. Okay, so I see from Mumbai router 3 point of view, 1.1.1 has taken up DR and 2.2.2 has taken up BDR. Okay, so if you see from the third router, that is from this router, this has taken up the DR state and this has taken up BDR state. Now, do you think that is right thing, or do you think that whatever the election has happened as of now, is that right? Now let's say you have powered on OSPF on three of them. So do you think, as per theoretical studies, this should have been taken up DR and this should have taken BDR? Yeah. So in our case, this should have taken up the DR. But what happens is, as we saw in the debug statement, first it takes up as BDR. Okay. Now, if it don't see any other router, it will make itself as DR. Now there is nothing called preempts in the case of OSPF. That when there's something else coming up, I must re-elect or go through the re-election and then become DR others or BDR and then give out this state to the better router. So there is nothing called preempts in the case of router. Either you have to reload them so the re-election happens, or you can kill the OSPF process so that re-election happen, or the re-OSPF neighborship are built up. Okay, now this command is very important command. In case of production, you cannot go with the first approach of reload, so you have to rely on the second approach. Okay, and the second approach is that kill the OSPF process or format the OSPF process and rebuild the neighborship. Okay, what is the command? It's clear IP OSPF process. Type yes, it will go through the re-election. Clear IP OSPF process. Yes. Clear IP OSPF process. Yes. Okay. Now the three will renegotiate. The BDR DR will form once again, and then we should be able to see some better results. So let's see. Okay, now looks like it has worked. Okay, so now 1.1.1 has taken up DR others. That's fine, because 2.2 is much better than 1.1, right? So out of three routers that we have, one will take up DR, the second would take BDR, so the left out would take DR others, right? And from the IP address, it's very clear that 3.3.3, which is a highest router ID, will take up DR. The next is 2.2.2 and then 1.1.1. So very easy IP address that I have taken up here so that we can understand this. Okay. So if you see over here, 1.1.1 full and DR other. In this case, it has gone through the full state. Okay. In the case of DR other, but you will see DR others also placed in two-way state. Okay, so that's an interview question. So let's say if you see two-way DR other, don't think that this is stuck somewhere or this is a bad example. In fact, this is a good example itself. They have formed the neighborship, but they are not participating on any hello packets, or they are not participating on any LSR packets. Okay, they are just uh, kept as it is. As soon as there is requirement, they will be put up into the full state. Okay, so that is just to avoid any extra overhead on the routers. Okay, so in this case, as soon as they got the three got elected up, this took the full DR other, this the second one took the full BDR. Now who has taken up the DR? So how can I see? I can see it from the different routers. So if you see now, the 3.3.3 has taken up the DR process, okay, or the DR state. There is other ways to confirm as well. So it is show IP OSPF interface E0/0. Now if now this is very useful command in case of OSPF. Okay, very useful command. So this command is going to show you that the state of this router is DR, the priority set is 1, okay, and it's a broadcast type of network. Now broadcast is nothing but multi-access network type, and by default OSPF will take broadcast type. Now you might be thinking, how many different types do we see? So you can see point to point, or point to multi-point. You can see broadcast like how you see as of now. You can see non-broadcast. Also you can see loop back. Okay, so we will check it out after some time. So these are the network type that's been put up here. So in the case of this scenario, the network type taken up is broadcast, okay, because it's placed in a broadcast. Also by default OSPF is going to consider broadcast only. Now let's say if you want to change this to point, you have to go to the interface and you have to say IP OSPF network type as point to point, okay, in case you want to change that. But in the case of default behavior, it will take up broadcast. And in the case of broadcast, this is the cost value, okay. We will talk about cost calculation, how to manipulate the cost, but as of now it has taken this cost value of 10, okay. The designated router has taken up the IP 3.3.3, and you know that what is this IP basically. So basically this is the router ID. In our scenario, this is the router ID. There are 3 steps to get the router ID. One is manual configuration, highest loopback, or else highest physical interface. So as of now, this is highest loopback address, okay. The interface ID is this 23.12. And by default, for a broadcast network type, the hello and dead timer will be 10 second and 40 second, okay. And one more interesting thing about this, when you compare with EIGRP is, so let's say I have OSPF on one end and I have EIGRP. Now let's say I change the timer or the hello timer, I'll make it as 5 second. So automatically the hold timer will be calculated into 4, which brings up 20 second for hold timer or dead timer. But in the case of EIGRP, it doesn't do auto calculation. So let's say by default it was 5 and 15. Now you just change to 10 second. So don't think your whole timer would have been into 3 by default. That's not the case in case of EIGRP. You have to manually bring that. But as per EIGRP best practice, the whole timer are not meant to be changed, okay. It's always preferable to keep the default values. And on a side note, there will be no auto calculation, that what we see in OSPF. In OSPF, if I change hello timer, it will automatically multiply with into 4 and bring up 20 second as a hold timer, okay. Okay, what else over here? So basically it will say, it will show you that it's the neighbor count is 2, adjacent neighbor count is 2, adjacent with these neighbors, okay. And why is this command important? So let's say in future I bring up authentication, okay. Now authentication, let's say during your examination, or let's say during your lab exam, you do not have access to the show run command. So you might be aware, when you write lab exams, lot of commands would be taken down, okay. So let's say there is nothing for show run. So let's say your task says, or your task is about to find if there is authentication enabled or not, okay. Now what is the quickest method to do that? I would go to show run, I would put session OSPF, and that would have given me the complete configuration, and from there I can just pick up the right answer, whether it's configured or no, authentication is configured or no. But let's say this command is being taken down, or this command is not working. Now there is no way you can find authentication is enabled, okay. So in such scenarios, this line or this particular configuration helps you. So when you type this command, which is out of the run, there is nothing called run. It's not a running configuration. It's a straightforward CLI command. Okay, show IP OSPF interface, and over here you will see the additional two lines which says that the authentication enabled is plain or MD5, and what is the key or all those things. Okay, so we will see this once I configure authentication. Fine. So this was regards to the DR and BDR election. Okay, now let's see what else does our workbook talks about on configuration. Okay, so we know what is OSPF process, we know how do we enable debug comments. Okay, we have verified the three tables: neighbor table, database table, and routing table. Okay, now let's see what is the routing table when I have the three routers placed under OSPF. So you have the two destination network that's been learned over OSPF. Okay, fine. So what else? Okay, what is the formula for DR and BDR? It's priority plus router ID. By default, priority is 1. If you make priority to 0, then that will not participate on DR and BDR election. Okay, and this happens in the two-way state. Now when is master and slave happening? It's happening in the extract state. Okay, and the formula is highest router ID. Only highest router ID will be taken up as master. So there are scenarios. Now again there is an interview question over here. So let's say I have three routers. Okay, now someone asks you to find DR, BDR and master and slave. Okay, and let's say you select the DR. Let's say this is 3.3.3.3, which takes up the DR election. This is 2.2.2.2, which takes the BDR election, and you got 1.1.1, which is DR others. Okay, the interviewer asks you now who is master and slave. So don't be getting confused. So DR and BDR is for a complete segment or complete topology, whereas master and slave is between individual segments. Okay, so your master and slave will happen on three different segments, whereas your DR and BDR was elected throughout. Now, there is one more confusion here. Don't ever think always the DR would be the master. Okay, don't be in that confusion that let's say this is DR. Now, this has to be the master always. No, it is not really required. Okay, the reason is, what is the formula for this? This is priority plus router ID. Now, let's say if you bring up a high priority, let's say the priority is over here 1. Okay, let's say this router has priority 1, this router has priority 2, and this router has priority 3. Now who is going to win the election? That is this router. DR will be elected as this because of the highest priority. The first thing that gets checked up is priority. If the priority is a tie, then it goes towards router ID. Now in this case, the priority are three different terms. So in this case, this is going to be DR. Now when you talk about the segment, it's just the highest router ID. Now which is having the highest router ID? That is this. So this is going to become master. Okay, this is master, this is DR. So that is why don't ever blindly assume that always the master would be DR or DR would be always master. You need to know those formulas. Okay, the two formulas. So let's say in this two scenario, this takes up the DR. Okay, let's say throughout I have DR taken, so this would be BDR because this is the second best, or because of the priority, not because of router ID, because priority is different in this case. But when you talk about master and slave, it is segment based. So this will be taken up as master, this is as slave. This is master, this is slave. And when you have these two things, you have already selected DR, BDR, DR other. So there is nothing uh, happening in terms of that election. But in terms of master and slave, this will be taken up as master, and this will be taken as slave, and the master will start sending the database synchronization or the copy of the database synchronization. Okay, so this is what happens uh, in case of DR and master. So don't think they both are same, or never think that always the DR should be master or master should be always DR. They can be any sorts of scenarios. Okay. Okay, a common troubleshooting OSPF scenarios. So let's take for an example on my this topology. I have a very lower end router which is 800 series, and rest of them are 3750 ISR boxes. Okay, 3750 ISR boxes, integrated service router, and this is one such or one of the older box. Now because of the loopback address, it has taken up DR. Okay, now what happens is, in the case of multi access network, whole update will be first pushed to the DR, and then DR will update its database, and then DR will send the updated packet to all other router. Now why should I need, or why should I bring up this as a DR when I have other better routers with better or the latest hardware which can become a DR as well as BDR? Why don't I shut this down, right? I can shut this down with the priority 0, so that they don't elect themselves as DR or BDR for any reason. Okay, but they will still be part of OSPF. They will still be part of OSPF with DR others, but they will never form DR or BDR. Okay, so in such scenarios, let me show you how do I manipulate the DR BDR. Okay, as of now, this router, that is the third router, has taken up show IP OSPF interface E00. So if you see, this has taken up the DR relationship or DR state. Okay. Now what I do is, I go to configuration T, I go to interface Ethernet 0/0. I say IP OSPF priority, and if I do question mark, I have 0 to 255. By default, 1 is taken up. Okay. So you see here, by default 1 has been taken up. Now what I do is, I don't want this to be DR or BDR at any point of time, because this is a lower end device. I have all other devices much better than this one. So I set this as priority 0. So once I do this, so let's see if the recalculation happens or not. Okay. So I am shutting it down, not complete shutting it down. I am just making sure that it don't form DR and BDR. Okay, so you can see the recalculation or the election is happening. So let's see now what has happened in the backend. Show IP OSPF neighbor. So this has taken DR now. 2.2 has taken up DR. Now who is left? Who can take the BDR? It's only 1.1.1, because your 3.3.3 is no longer going to participate, right? So how do I verify? With this command. So if I show this, if I see this show IP OSPF interface, it has taken up DR other role. The priority is 0. Okay, and if you read these 3 lines, it say designated router is 2.2.2, backup is 1.1.1, and this particular was your older designated router, but now it has been taken down, or it has been taken out the DR relationship. Okay, I'll confirm it from one of the neighbor router. So if you see now, your 3.3.3 is full DR other. Okay, let's make sure let's make sure that setting priority 0 will of course not bring this router. So let's say, so what we have done right now is, with the help of priority value, I have of course changed the behavior. But what if my one of the router, now let's say if 2.2.2 goes down, so your 1.1.1.1 will be taken up as DR. but do the 3.3.3 will come up as BDR or no? Now that is a question, that is something which we need to do a practical and check it, right? So something which we need to check, right? So that would make sense that priority 0 will not bring this on DR BDR. How can I do that? I just go to the second router which is acting as DR at the moment. So this is a DR, okay, on interface this. So I just shut down that interface. Okay. So let's see what happens now. Show IP OSPF neighbor. So neighborship are gone down from this router. What about from the opposite router, the neighbor router? It has not taken down. The reason is the hold timer, the 40 seconds of hold timer. It is going to wait for 40 seconds. It is sending consecutive 4 hello packet, and if there is no response received, then that's going to get taken down. Now you can see this timer got lapsed and now it has been taken down. Okay, dead timer expired. Now if you redo the neighborship table, you do not have anything over here. Okay, so you don't have 2.2.2 neighbor. Okay, now regarding, come back to the first point, that is when you set 0, do they participate on DR BDR election? So they don't participate. That is what this task was, to see when you set priority 0 and the circumstances are that there is only one DR, there is no BDR. Now if you see from different router, let's say from this router, there is only one DR, there is no BDR. Okay, there is only one DR and there is one DR others. That was the main thing that to be checked here, right? In case if there is no BDR, will this priority 0, which is a DR others, will be brought up to BDR, but that will not happen. So that proves that once you set priority 0, there will be no DR BDR happening on that particular router. So come back of this, I'll bring up that interface. I'll also change the priority back on this because I need to take up this lab for the next task. So I don't want any kind of configuration overlap this. Okay, so IP OSPF priority 1. And what did I say? There will be no preempts happening. So you have to kill the process and bring up the re-election. Okay, in the case of OSPF there is no preempt, so you have to either reload or you have to kill the process by clear IP OSPF process, which will bring this router once again DR because of all the theoretical topic that we discussed. Okay, fine. So let's go to the next task. The next task is router IDs election. Now this is something which is been discussed over on the theoretical topics. Okay, the 3 steps here, one is your manual IP that can be put up as a router ID, or else it's going to take the highest loop back. If there is no highest loop back, then it's going to take the highest uh, physical interface IP. Now let's say there is nothing, then your OSPF will not even come up. Okay, fine. So and a little bit about router ID is it's IPv4 format. Okay, it's a 32-bit IPv4 format. Now let's say when I am configuring OSPF on IPv6, OSPF v3 on IPv6, so the command would little change in the case of OSPF v3. Okay, so you router OSPF v3 and so and so. Okay, and then you need to advertise the network. How about the router ID? So do you think the router ID will also be in the IPv6 format? No. Okay, so in the case of router ID, it will be still following the IPv4 format only, IPv4, which is 32-bit format. So that's something which is a strange thing. Okay, in the case of IPv4 IP, and also in the case of IPv6, the router ID remains the same format, that is the IPv4 format. Okay, so you will see it usually in this format. Let's say 1.1.1 or 192.168.32.1. So basically this will be taken up as router ID. So let's see this on a router where I have not configured any OSPF. Okay, I do not have any OSPF. I do not have any. Okay, I do have some IP. Fine, that's not an issue. Okay, so I can take down those. Okay, so this will default my configurations. Okay, oh sorry. So there is no IP address. Okay, so let me show you what happens when I try to configure OSPF process or router OSPF 1. So it's going to say there cannot be any OSPF process created because there is no router ID or there is no IP that can be allocated to router ID. So what I can do is either I can come out of this, I can go to the loopback, or I can go to the physical ID. But the first preference is manual configuration. So I can also set it up. Okay. So router ID, and as I told you, it only has one format, IPv4 format. So let's say this is 10.10.10.10. Okay, now this is where your OSPF is all capable of sending the hello packets. Okay, hello packets, because it has a valid router ID, and rest all the details or the other parameter like hold timer, hello timer, they are default. Okay, by default those packet will be kept, or those are defined values. So until you change something, they are going to remain the same. So let me show you. If I see show IP OSPF, so let's say do debug IP OSPF packets. So this is a state when when you have brought up the OSPF process. Okay, and they are ready to be sent out, but they need a interface, or they need an interface where this packet can be taken out. Okay, so as of now I have not configured any interface. Okay, so once I have the interface, we can see on the Wireshark that the outgoing interface is taking up hello packet. Okay, so this was the first step here, that is configuring router ID. So let's say I configure some network. So I'll just configure a whole network. Okay, area 0. Okay, so if I open up Wireshark, so this is a router 4. So if I open up Wireshark over here, so you can see the OSPF packets. Okay, so over on E0/0, let's give some IP which I have taken down. So this is the IP 255.255.255.0, no shut. Okay, see what happened. As soon as you have the interface coming up, your hello packet will all sent. Okay, so you can see the new neighborship happening here. Let me show you the router ID from the point of router ID. So this is designated router with 192.168.23.11. Do show IP OSPF neighbor. So if you see now, there is a DR other with two-way neighborship. Okay, so it doesn't mean that this DR is having some issue or something. Okay, is that it's just placed under two-way relationship. Now if something goes down, it will be continuing the rest of four state, that is extract, exchange, loading, full, and then it will be put up into full. Okay, so this is a good example itself. Okay, so I was showing you router ID. Now this is a router ID, source OSPF. Okay, so in this case you can see 1.1.1, 3.3.3. This is 10.10.10. Okay, 2.2.2. So this is the router ID which is taken up, which is the header of the hello packet, and within the hello packet you will see all other parameters. So let's discuss those parameters. Okay, so router ID we just discussed. Now in the case of OSPF, there are certain parameters that has to be matched. So when I have R1 and R2, when the router ID has been taken up, okay, so let's say this is the hello packet. So hello packet will have something called OSPF header. Okay, now this OSPF header will consist of router ID. So that is what we checked here. Okay, so your hello packet will have something called OSPF header, which will have router ID embedded. Okay, and this router ID and this router ID, which is part of OSPF header, will carry the hello packet. Okay, and the parameter of hello packet in the case of OSPF R, that must match on both the side, that is your hello and dead time interval, they must be same. Okay, you have authentication, you have area type, area ID, subnet mask. Okay, so these are some parameter which will be stored over here, and this will be transported, okay, on the multicast address. Similar way, you will also receive the hello packet from the second router, which will follow the similar pattern. So you have router ID and the rest of hello parameters. Now we need to check one after one by manipulating the timers and all those things, what happens to the relationship, whether they lose the relationship or no. Okay, so what I do is, let's say come back to the first router. So this router is having a neighborship, OSPF neighborship with 2.2.2. Okay, and what is the timer that they have by default? So they have 10 and 40. Hello, dead, wait, and retransmit. Okay, so let's see from the second router, show IP OSPF interface E0/0. Now that's having 10 and 40. Okay, ignore these two things. That's not important thing. Wait is nothing but dead timer. Okay, retransmit is nothing but to retransmit the packet. Okay, so ignore these two things as of now. Focus on hello and dead interval, which is same on the both side. Now let's say I go to conft, I go to interface E0/0, I say IP OSPF hello, and I just set hello timer to 30. Okay, now let's go back to that same command and let's validate the new change. So let's say do IP OSPF interface E0/0. So you can see this has been shifted accordingly. Okay, so I just had to change 30. The dead timer got automatically shifted into 4. Okay, in case of OSPF it is into 4. In case of EIGRP it was into 3, but the shifting will not happen in case of EIGRP. In case of EIGRP you have to change hello as well as dead manually, but in the case of OSPF it will auto adjust the values. Okay. Now what happened? The neighborship started coming down because the hello packet must be same on both the side. So from this point of view, if I just see the neighbors, so I have a neighbor relationship with 3.3.3. Okay. What about with this? So basically it says that, okay, so one more neighbor gone. Okay, so let me refresh this. So you can see 1.1 is taken down because of the mismatch in the hello and dead timer. Okay. So interesting thing over here, if you are still thinking, if you just are confused that you have changed this timer, but the relation with 3.3 is still present. The reason is the hold timer is now increased. So it's going to wait for couple more of uh, seconds, and then it's going to take this down. Now that is a drawback in the case of setting higher timer. So don't set 30 and 120 in OSPF. Okay. So in this case, if you see, the network is down, but still it's waiting for 120 timer or 120 hold timer. So the best practice is 10 and 40 in a normal LAN segment. Now let's say 10 and 40 itself is a large number. Now you can bring it down. You can make it 1 and 4. Okay. Your OSPF will support 1 second also. Let me show you that. Okay. So you have 1 second starting from 1 second. So let's say I make it 1 over here. Okay. So what is going to be the dead timer? It's going to be 4 second. See. Now this is very high in number. You can expect lot of fluctuation happening. Now this itself can bring overhead on the devices. So don't keep 1 and 4 until you are very specific about your network topology. Okay, don't keep 1 and 4. That's not actually good. A slight fluctuation can bring down that neighborship and can unwanted overhead will be increased in the routers. Okay, so just keep 10 and 40, which is a standardized, but yes, you can bring it down. That was my point. Okay, in during interview, lot of time I have seen the interview asking what is the minimum configuration that you can set for hello timers. Okay, so you can set it up 1 second. Now let's say if interviewer ask you that I want timer, or I want this hello timer in milliseconds. Okay, so as of now you saw this was the lowest was 1 second. Now there are some interviewer who will ask for millisecond. Now in that case, what you can do is you can bring BFT, by forwarding detection. Now we will discuss this in later on classes, not under OSPF. This is a additional feature. When you bring it up with OSPF, you can bring down the hello timer in milliseconds. Okay, so it's from interview point of view only. Fine. So let's see what happened on a Wireshark now. Okay. So I just manipulated the hello timer of this router. So I believe the hello timer on my capture should be shown up as 1 second. Okay. So if I go to OSPF, okay. Actually, there are multiple filters for OSPF. Okay. So if you want hello packets, you can still go ahead. So it's going to give you, it's going to narrow down the things. Okay, so let's say I want to go with hello interval. So you can see the result is just showing for 1 second only. Okay, if you just take down this filter, now what happens, you will see this for the complete output, or the complete packet. So you can see for 10 second, the R2 is sending on 10, the R3 is sending 10, R4 is sending 10, right? So you will see the complete output 10, 1. Now if you want to filter up, you just need to filter out and just see the 1 second packet. So you just have to filter it up with OSPF hello interval equals to 1 second. Now once you do that, so the result will show only those packet where the hello interval is set up for 1. Okay, so you can see the hello packet contains the hello interval and dead interval, and don't change them because they are going to bring down. So I'm going to make it 10 once again. So once I do that, my packets will be taken up back on the 10 second, and then the parameter should match, and the neighbors will come up. Okay, so you can see the neighbors have started coming up. So do show IP OSPF neighbors. So you have the relationship once again up. So that was regarding to the hello and dead time intervals. Okay, now let's talk about the next step, that is changing the area ID. Now area ID is also very important thing in case of neighborship formation. Okay, so why do I say area type? So this is okay, not area type, area ID. Okay, so there are two things, area ID and area type. Now at this moment I'm talking about area ID. So area ID is also the part of OSPF packet which has to match. Okay, so on my router 1, so as of now there are successful neighborship. Now let's go to OSPF 100. Okay, now let's see what is the default configuration. So this was the configuration. Now what I do is I just take down this network. I just put no. Okay, and I configure a different area, let's say 100. So what happens is OSPF is going to lose the neighborship relationship. Okay, it's going to say mismatched area, and we can validate that. So as of now what I do is active neighbor designated router hello interface ID network. Okay, so if you just capture the traffic for, so let's see for 11, so you can see the area ID. Okay, now again there is a little theory behind this. So you see 0.0.0.100. Okay, but if you see from the CLI, what did I set? I had set area 100. Okay, so on my CLI I had set area 100, but on the Wireshark I see it in IPv4 format. Okay, so don't be confused, this is nothing but decimal to IPv4 format. Okay, so this kind of conversions are called as decimal to IPv4 format conversions. There are couple of websites where you can practice those conversions. So let's talk about one of such reference website. So if I take up my browser, okay, so let's say I have area ID 100, and if I click on convert, Now that's going to show us 0.0.0.100. So that's why I can see this. So don't be confused in case of technical rounds or in case of certification. Okay, the area ID that is shown in the Wireshark is in the IPv4 format. Okay, but in the case of CLI, we make use of the decimal notation. So in the case of, let's say I put area ID 42. Now that's going to be this. Okay. Now let's take a very large number. So let's say 32768. Now if you convert, that's going to be this value. Okay. So this proves there can be multiple areas in the case of OSPF. Let's do question mark. Okay. If I do question mark, this is the range of area. Okay, if I just take up this value, the maximum or the largest value, and if I put up here, so you will see this is the maximum, or this is the last area ID that you can have on your router. Okay, it doesn't mean you will have so many areas, but yes, as per your network design, you can have any area numbers. Okay, area 0 is backbone, you need to have that. Okay, but attached one, or the linked one, they don't have to be like 1 to 40 or so on. You have plenty of them, you can go with a very large number. Okay, just for your network design. Okay, there's no reason to have that. It's just to for your network design. So my point here was, this is the IP conversion for the area ID that's supported in the routers. Okay, so this over here in the CLI, it is decimal notation, and over on Wireshark, that's get converted to IPv4 format. So I'll put back this. Okay, so that I bring up the neighborship. Okay, so the neighbor should come up now. Okay, fine. So that proves that you must have the consistent area IDs. If you do not, then they will not form neighborship. Okay, so during the configuration, let's say I have this kind of topology where I have area 0, area 100 and area 200. So the neighborship formation will happen locally within those areas only. In case of area 0, the routers which are part of area 0 will have neighborship. Now routers which are configured on area 100 will form neighborship, and same thing with the 200. Okay, so this router and this router don't form neighborship. Okay, the neighborship is local to the area. So you cannot have the two routers over here have 0 on one side and 100 on other side. Now that's a mismatch. Okay, and that's a part of hello packet. So don't configure a wrong area IDs. Okay, now what next? Area mismatch done. So this is something which you get. Okay, regarding authentication, as I was telling, there are two types. There are two ways to configure, and also there are two types of authentication. So it's called plain text and MD5. In the case of plain text, there are two ways, as well as in the case of MD5, there are two ways. Okay, so what is the difference? So basically, in the plain text, you can see the password, the passwords are visible. Okay, the passwords are visible, so that's not a best practice. In the case of MD5, the password will get encrypted, or they will be encrypted, so that no one can see what is the password, or what in a plain text format. Okay, so what I'll do is I'll configure authentication, and we will prove that having one side authentication and on other side no authentication can also bring down the neighborship. So as of now, there is a successful relationship. Now, as I told you, there are two ways to configure. Okay, I'll do both of them. One is centralized way, which is also called as global way, and the second one is called interface way. So let me do on Mumbai router 1, the global way, and on the second side I'll do interface way. So let's go to router OSPF 100. Let's say area 0. Now I have two ways to uh, assign my area. I can put area 0, or I can also put in IPv format. So both are same, okay? Because we know the theory behind these two things. So you can set whatever the way you need. So let me go with this. Now what is the authentication that I want to set? So let me pick up that authentication, and let's say I want MD5. Okay. Now which is the interface that's participating on OSPF? It's Ethernet 0/0. Okay. So as soon as you set authentication, it's going to say there is no valid key and all those things. Okay. But the neighborships are still not down. The neighborships are still not going down because you have not called this authentication on the interface. So we can also check that. Okay. If I just open up the Wireshark, so you will still see the packet without any authentications. Okay. Because you just have defined it, you have not called it or on the interface. So until you call it on the interface, they are not going to be part of authentications. Okay. So looks like it has taken up. Okay. So let me once validate. Do show IP OSPF neighbor. Fine. So it has taken up. Okay. As soon as you bring up inside the globalized way, the packet start considering this changes, and it has taken down the neighborship. Okay. So basically, what happens is this should not be bringing up the change until we have defined under interface. Okay, because under interface it is still not been defined. Anyway, so let me define the password. Okay, so as of now the encryption will be enabled, but the password will not be set up. So if I show you the Wireshark capture here, okay, so I was talking about one of the other command, show IP OSPF interface E0/0. So if you see here, now you can see that authentication has been enabled, but there is no key configured. Okay, so there is no key, but the authentication reads out to be enabled. Okay, so let me configure one of the keys. So I'll go to the interface. I'll say IP OSPF authentication. So now at this moment I have to set a key. Okay. Okay. So the command would be message digest key. I'll set one of the key. I'll make use of MD5, and I'll make use of the password. Okay, Cisco. Now the key over here, it's called as youngest key. Okay. Now there is a small theory behind this youngest key. You can have multiple keys. Okay, that is used in the scenario when, let's say, I have R1 here, and R1 is forming OSPF neighborship with three of different router. Let's say this router will connect to customer A, this router is connecting to customer B, this router is connecting to customer C. Now you don't need to set the same key on all the three links. I don't have to keep Cisco and Cisco on all the three. Okay, because might be the key has given by customer itself. So let's say he's giving his side of key. He's saying it must be customer A. So what you can do is you can go to key number 1 and you can set this key customer A. Similar way, let's say this customer is giving his own key. Now you can make use of the second key number 2, and you can set customer B. So what happens is, in the case of neighborship formation, the keys will be taken up in sequential order. Okay, it will start with key number 1. So let's say there is a neighborship happening between this. Okay, so it will first go and check key number 1. Key number 1 is set for customer A. Now that will not bring up the neighborship. Next, it will go towards key number 2, which is the right key, which is set for the customer B, and now they will negotiate and they will form OSPF neighborship. Okay, so these are the keys that represent with different customers, different networks, or different vendors, or different reasons. You can have multiple keys. Okay, so if you see this, when you see this over here, so don't be confused. It's nothing but it's talking about the key number. Okay, so if I bring one more key, now this will be put up as a key number 2. So let me show you that. Okay, just for demonstration purpose, I'll bring one more key. Okay, so let's say I have the second key over here with the customer B. I have one more key, let's say for customer 3. I call it as customer C or 3 or whatever. Okay, and now if I see the interface statistic of this, so you can see the youngest key ID is 3. So whichever key you configure, or whichever is the latest key that you configure, will be taken up on this interface. So in this case it was 1, then you bought the second key, and then you brought the third key. So basically there are 3 keys. Okay, if you see the total configuration, do show run, let's say key, so you can see there are 3 different keys. Okay, and that will be in a sequential order. It will first see the key 1, key 2, and key 3, and the one which get negotiated will form the authentication. Okay, now let's go back to the authentication factor. Okay, so let's say this is the key that I have made use of. So on the second side, I'll make use of the same key itself, that is on the second router. I go to router OSPF 100. I will enable the authentication with the command area 0 authentication message digest. Okay, I'll go to interface 0/0 and I'll set this key. Okay, so now let's see what happens. So basically the neighbor should form now because of the matching parameter. So you can see this neighborship has come up. I agree. So if I do show IP OSPF neighbor, so you can see the neighborship coming up. Now let's say I just change this key. Okay, I just change the key. Okay, let's see what happens. So you can see the dead timer is decreasing. It went to 30. Okay, so you have the youngest key as 2, and it says roll over in progress, one neighbor using the old key ID is 3, and algorithm is MD5. As I told you, on the other side I have configured 1 2 3. Okay, so it's basically rolling over. So basically it is going to negotiate and they are going to synchronize. Okay, so on this side, show IP OSPF interface E0/0. Okay, so you have, it says youngest key is 3, rollover is in progress, one neighbor using the old key. So basically they will negotiate and they will have the same key ID being mapped up. So you can see this. Okay, do show run include key, and if you see this do show run include key. Okay, so that is why. So basically they will negotiate and they will have one of the latest key put up. So in this case you can see there is a rollover process going on. They both are aware of key number 2 and key number of key 3. Now this router, let's say this is a customer end router, it doesn't know about key 1. Now that can be configured on this router, which is another customer with key 1. Okay, so basically they are having different keys. Let's say customer A, B, C, D, they have multiple keys, and on our side I have information of all of them 1, 2, 3, 4, and so on. So basically they will be negotiated in sequentially and they will form neighborship. Okay, fine. So what are the next step after authentication? Now, once again, authentication is optional. Okay, if you set across everywhere, make consistency, keep consistency. If you don't set, keep it default. Okay, but don't set password on two of them and then rest of them you're just ignoring it. That will bring down your OSPF relationship. Okay. Fine. Regarding area type, now this is something which comes with respective to LSA type. Okay. Let me tell you what does it say. Okay. So there are multiple area types like stub, not so stubby, total stub. Okay, so now these are special area types. Now let's say what are the normal area types, like area 0, you have area 1, 2, 3, 4, so on. These are the normal areas. These are special areas. Okay, if a router fall in one of them, okay, and on the other side the routers fall under one of them, these, then they will not form neighborship. I mean to say, let's say I have area 0, I have all my routers where the area will be configured as 0. Now let's say by mistakenly you configure one of the router with area type stub. Okay. Now what happens is the hello packet will carry that information called as stub, and this router will not form neighborship. Okay. So this will not form neighborship because of different area types. So the area types must be same. So that means if you have uh, falling, if you just turn this off, or if you keep them off, or no area ID configured or no area type configured, then they will be part of one of the standard areas. It could be 0, 1, 2 or anything. But let's say you configure these special areas. Okay, then make sure they are being configured across all of them. Let's say this whole bunch of routers falling under this area was stub. Okay, in that case you have to configure this stub on every routers. Okay, so don't miss this word, keyword called stub, that will bring down this. Okay, now what is stub actually? So let's say I have area 0, I have area 1. Now my company just by another company which is running on EIGRP or a static route or anything. Okay, and let's say I have users who wants to talk to the users of my company, or my users want to talk to the users of the other company. Okay, so I need to bring some routing. So basically I can enable redistribution. So what is redistribution going to help me, or how is redistribution going to help me? It's going to inject all the EIGRP routes within OSPF, and OSPF routes will be injected to EIGRP. So they form a single channel and they will be talking to each other. Now this external route, which is a part of EIGRP, when they enter OSPF, we call it as external route from the point of OSPF. Okay, from the point of OSPF, anything apart from OSPF, it could be EIGRP, BGP, RIP, anything, they are called as external route. Okay, and these external routes are labeled with LSA type 5. Okay, so we discussed today LSA 1, 2 and 3. Okay, 3 not in much detail, but I just gave you an overview. 1 and 2 in detail. Okay, 3 is again a single area concept, or sorry, not single, it's a multi area concept. But now we are talking about multiple protocols, or two different autonomous protocol. Okay, so that is when your LSA 4 and LSA 5 will be coming in, when you have OSPF and on other side you have EIGRP. Okay, and this route which is entering inside OSPF premises will be now labeled with LSA 5. Okay, so this LSA 5 can be suppressed in the sense I can completely take this down, because unwanted LSA or more number of LSA are nothing but it is increasing the overhead on my routers. So I can just bring them down by giving some default route. Now we'll talk this in the next class. I don't want to bring a lot of things. My point here is, when I say talk about stub and NS, the non so stubby thing, the stubs are nothing but they are external routes which enters OSPF. Okay, now how are these configuration going to bring down the neighborship? So let's say I have area 0. As I told, if you have like 4 routers, so you need to keep them as area 0. Okay, you don't configure the special area called stub. Now what happens, this will start advertising in its hello packet that I have stub configuration in me, and that's why I'm not able to negotiate, or I'm not able to form neighborship. Okay, so let's see what is present at this. Okay, so there are a lot of, okay, let me take up one of other router. Okay, I don't want to take the config, bring the config, because we are running out of time. Okay, so how do we configure these special area types? So let's say router OSPF 100. Okay, so I say area, let's say area 100, and it's on stub configuration. Okay, so when I bring this configuration, so the neighborship relation will go down. Okay, and I'll show it from the Wireshark point of view. So where is my fourth router? Fourth router is here. OSPF hello, router priority network hello. Okay, so let me take up for hello packets. Okay, what is that interface that is advertising? It should be 23.14. So this is the one. Okay, that's my hello packet from router 4. If I open up, if I elaborate this, okay, so you can see the external routing is capable right now. Okay, do show run. Oh, sorry, it is not 100. It should have been under 1. Okay, so there is a typo in case of process, because we are having process number 1, not 100. Okay, now we should be able to see this type. So on 14, no router OSPF 100. So this is one extra command which is not a good for neighborship. Okay, so they'll just come down. But what I am expecting is on Wireshark, you must see the change over on this factor. Okay, stub or LSA 5 is nothing but external route. So once you bring up that stub configuration, you must see this external features going down, and it must have shown the number 0. When it doesn't support, it shows 0. When it support, it shows 1. Okay, so might be the interface is down or something. So let's once check. T314. Okay, anyway, I am expecting this to be 0. Okay, so when I have the stub configuration, so basically this okay, or might be I should have shown it in different area. Okay, because I cannot bring area 0 as stub. So what I'm trying to say is, let's say if I try with this command, it will not let me to happen. So I should have shown you this example on different areas like area 1 or area 2. So on those scenarios, we could have easily have seen those commands. Okay, okay, so might be that is the reason. In case of area 0, backbone area, you cannot turn the external routing feature. So that's why it's always 1. So that command, the extra command, the stub command, is actually not effective at this moment. Okay, because we are on a area 0. On area 0, you cannot suppress the external routing. If it was any other area, then this extra command would have automatically suppressed the external routing. So that was my point here. Okay, so if you get time during weekends, give a try, make that change and just see how it behaves on Wireshark. Okay. Okay, fine. So I'm almost done. One last thing. So basically, so far we discussed about all the hello parameter that should match in order to form neighborship. Okay. Now there is one special issues, or I don't say special issues. There is one more interview question that's that's like when interview ask you that my neighborship are stuck on extract or exchange. Okay, so when does this step happen? So basically, to reach extract and exchange, we have already gone through the two-way step. Already the neighbors have formed. And when is neighborship formed? When the two hello packets are matching up. So that means we have checked all the parameters like authentication, hello interval, the area type, area ID, subnet mask. So everything is fine, and we have crossed two way, and now we are stuck across on this. Now what could be the reason? So anyone of you know the answer for this can put up on the chat. Yeah, that's right. Okay, so that's a scenario. So let me write one quickly one last time. So it starts with down, init, two way. Okay, so all your hello packet, the parameters are all gone through, and then it goes towards extract, exchange, loading, and full. Now, if the interviewer asks you that the neighborship are stuck on this state and they're not moving further, okay, so it's because of the MTU, the maximum transmission unit mismatch. Okay, so I'll just show you. I'll just show you one such example. So let's say show IP OSPF neighbor. So it's in a neighborship with 1.1.1. Okay, so do we have authentication? Do show IP OSPF interface E0/0. Okay, so they are under authentication. Okay, yes, fine. I can show you one more thing before going to that. Okay, since they are under authentication, I would like to show how the authentication and how the checksum value are actually calculated. Okay, so if you see for the packets for 23.11, so you can see the authentication para or the authentication columns are now filled up. Okay, so you will see the authentication type, key values, data length, sequence number, and data, and there is something called checksum. Okay, checksum is nothing but the hexadecimal format of this authentication. So on the other side, on the other side, if you see, so when there is no authentication set, that those will be null. Okay, there will be no authentication. But as soon as you set some authentication field, you will see your hello packet or the header of the OSPF will start reflecting the authentication columns. Okay, okay, come back to the MTO thing. I want to show you MTO now. Okay, so do I have DPD packets? Okay, so what I can do is I will just bring one of the interface down and no shut. Okay, so I have the DPD tables. So I'm just trying to see the MTU column. Okay, I'm looking for that MTU where I can see. Okay, fine, over here. Okay, so why did I pick DPD packet? What is the logic behind taking DPD, not hello packet? Okay, so as we know, the seventh state down init two-way, which was all respective to hello packet, and now the point is or the problem is with extract and exchange, which is taken care by DPD packets. So this DPD packet has a field for MTU. Okay, now let's say MTU gets changed up on the one side. Okay, let's say on one side, let's say on the router 2, I go to interface E0/0, I say IP MTU 1500, or let's make it less. Okay, because 1500 is by default on interface, so let's make it as 500. Okay, let me make it as to reflect this, I have to bounce the port. Okay, so I make shut and no shut. So once they renegotiate, once the interface comes up, they start negotiating, the DPD packet will now carry MTU size. Okay, and now there is something interesting happening. So because of this DPD packet, which consists of 500 on one side and on other side 1500, they are going to get stuck. Okay, they are going to stuck exactly on this. So you will not see the rest of packets like your LSR, LSU and LS acknowledgement. So this is again an interview question which is very often asked. Debug IP OSPF packets at Gen C. Okay, if I go to interface, okay, so we should be able to see the logs straight away. Okay, so it says that received some packets, but they are stuck on extract. Okay, so let's see the config. Let's see the neighborship relation. Okay, show IP OSPF neighbor. So it's stuck on extract. Okay, it's not going further. And what about show IP OSPF neighbor? It is stuck on exchange. Okay, so the DR and BDR selection has happened. That's happening on the two-way state, and after the two-way state, it's going towards extract and exchange, right? So the mismatch of MTU is causing this issue. Now how do we rectify this? Okay, so yes, there are two ways to rectify. One is fix the issue. Okay, go to the interface, bring up that bring up the MTU size back to the default 1500, or you can just go and configure uh, ignore MTU. So let's say when I go to the interface 0/0, if I type OSPF IP OSPF and MTU ignore, so it's going to ignore that traffic. Okay, so it's in a down state. Okay, that's because of those authentication. It's better I take them out. Okay, okay, now it's working. Okay, so you can see the OSPF neighbors have formed. The reason is you have enabled MTU ignore. Okay, because of this CLI command, you have started ignoring the mismatch in the MTU. So that's why it's coming up. So that's a solution over here. Okay, either fix the issue or just bring up the MTU. So you can also fix the issue by going to IP MTU 1500 shut and no shut. Okay, and which will reflect the new MTU. Fine, that's mentioned here. Okay, okay, last thing that should be done for the day. Okay, that's regarding to the 2224.0.0.5 and 2240.0.6. Okay, we talk about two multicast IP. So in the case of multicast address, so your DR others to DR will be communicated on this multicast, and rest of thing like DR to BDR and DR to DR others would be on 2240.0.5. So why do we this is because we don't need the other routers which are DR others. Okay, let me write it here. So we don't want them to listen on those. Okay, so let's say one of the network over here is down. Now this dr other is going to update dr on 224.0.0.6. Okay, the rest of them are only listening on 0.5. Okay, the other routers don't understand what is dot 6. It's your dr only which is listening on this additional multicast ip. Now once dr update its link state database, that will be sent to all others. Okay, so it will be sent on 224.0.0.5. So let me see from my configuration if I have one of dr others. Okay, so let's see if I have something. Okay, so this is what this. What about this? No shut. Okay, so this will not come up because of the authentication issues. Okay, I just took down the authentication. Okay, looks like this is not the way to take this down. So anyone have the solution? Let me just check this. Yeah, I can do different areas, but what I was trying was to do it on very simple way. So anyway, what I do is router 1, router 2 and router 3. I'll set up router OSPF, let's say 10. Network, I'm going to advertise everything. Area 100. Okay, so let's give a try with this. Okay, so I'm just making use of a different area. I just need dr, bdr and dr others. Okay, and since we are running out of time, I just don't want to do trial and error and spend a lot of time. So just I need one scenario where I can show you something. So let's see, we have, okay, we have dr, we have bdr. Do show ip ospf neighbor. Oops. So basically this is a subnet mask and wildcard issue. Okay, so this should be 255.255.255.255. If not, then there is as good as nothing you're going to advertise. Okay, so put this under no and then configure. Okay guys, so I am actually tired up. I just don't want to. So we'll see this in next class. Okay, so just I wanted to show the two multicast IP, that's all, but I'm little exhausted. I just don't want to do it now. Okay, so let me see the Q&A, and if you guys have any doubt, let me know. Okay, so long list of chat history. Yeah, so this was happened, as I told you, there is no preempts in case of OSPF. Okay, so once they are configured in a timely manner, let's say you configured first router, then second and third, the first one will take the master or the dr election. Okay, and then later on, in order to bring the re-election, you have to make use of clear ip process ospf, so that re-election happen. And then yes, lsa1 lsa2 are both part of single area. Okay, we will discuss this about the cost metric regarding the 10 plus 1. Yes, this is something which we saw once we cleared the OSPF process. Okay. Yeah, we can clear the process, but we cannot reboot the router. Okay. So clearing IP process is only one solution which we can do, not in the production hours, of course, because the reconvergence might take some time for rebuilding the routing, right? So never do any production impact, but yes, after the production hours, you can do that command instead of rebooting. Okay. Okay, so regarding changing the priority, so priority will change the DR and BDR and all other things. Okay, whereas clearing IP OSPF is something where, let's say, you want to re-elect. Okay, so in case of re-election or in case of any changes that you do in your OSPF, they are not configured or they don't have a backend preempt configuration. So you need to kill the process and rebuild the process. Okay, otherwise most of the time, the even if you do the configuration, whatever configuration was been existing in those boxes will be considered. Okay, in the case of HSRP, when we talk about HSRP, we just saw that with the help of priority and preempts, we could manipulate the devices. But in the case of OSPF, we need to manually do that. There is nothing called automatic preempts. Yes, that's true. It doesn't bring up into election. Yes, if you bring this 0, it's just that they don't get DR and BDR, but they will have knowledge of all the link. Okay, they are going to maintain all the database of all the links. Yes, so this is just a single command. Might be I just ignored it. So what we can do is, so let's say I go to interface E0/0. I have already given the address 192 something. Okay, I can just go and say IP OSPF. What is the process ID? Let's say 10. What is the area that I want to advertise? Let's say 0. So this is just the configuration for enabling on OSPF. Show IP OSPF neighbor. Okay, so we have one neighborship. What about this? Okay, so looks like it has come up. Okay, so what can I do over here? So let's see why is this stuck on extract 23.14. That's IP address of this. Do show run interface 0/0. Do show run interface E0/0. Do show. Okay, anyway, he's wasting the time. Okay, yeah, so that's way we configure interface. Mismatch MTU, yes, that's why they get stuck on extract and exchange. One side of the network is not yet configured. So which is that network? So basically I have taken a few of them to demonstrate this. Okay, Yeah, so basically, I will be taking up broadcast and point to point. The rest of things, I don't think they are actually used in production. Okay, so for point to point, I have somewhere here which I'll take in the next class, and this is something in the case of broadcast. Rest remaining like point to multicast or non-broadcast. So basically, what happens on those point to point links are we need to manually configure the OSPF neighbors. Okay, so that's little difference between the normal point to point and in the case of the non-broadcast. Okay, and also the timers will be different. Yeah, so basically, when you have broadcast, so broadcast cannot be neighbor with a point to point kind of routers. The reason is on other side you have different timers, and on this side you have a different timer. So due to the timer issues, they can be mismatch. So basically, they must have the same network type. Yeah, this will be taken up in the next class. Whatever we discussed today was just the part of the class, so that's why I just took that. But yes, we have lab and we have a dedicated class for this. Yes, that is right. So, in the case of non-broadcast, in the case of point to multi-point, we manually need to specify the neighbors. Okay. Whereas in the case of point to point and broadcast, we don't do that. Okay. So basically, these are outdated ones. Like in the case of frame relays, ATMs. So those were the technology which used to be on non-broadcast, and so we don't see those technology nowadays. Okay. So we see by default on broadcast or point to point. So that's why I will focus more on these two. Exchange state has DPD packet. Yes, that's why we focused on DPD packet to see the MTU values. Okay, so basically with this command, I am ignoring the mismatch in the MTU interfaces. Okay, so when my packet arrives with let's say the DPD packet arrives to my router, it also is associated with the MTU value. It's going to say that this DPD packet has a MTU of 100 bytes or have a 1500 bytes. So that is why there will be a mismatch happening. So with this command, with MTU ignore command, basically we are going to ignore that MTU mismatch factor. Okay, so that is one way to avoid this issues. But better would be fix the issue, not uh, do a temp fix or something. Just permanently fix the issue by changing the MTU back to the normal. Okay, so guys, any further doubt? I believe we took a lot of time today. Okay, so because we all are from different time zone, so I just don't want you guys to be over here. So guys, let's meet up in the next class. I'll pass on everything like workbook, video and all those things. So we will discuss the rest of things in the next class. Okay. Have a nice day and see you soon. Take care.